So hello and welcome friends to our channel Intromech, where we discuss about basic mechanical engineering concepts and many other things which are related to industrial automation. So guys, we have started our new series which is related to industrial robots, and in our previous sessions we have discussed about what are the basic components of the robots, then what are the links, what are joints, then what are the different types of motions the robot have, then the terminology is included in the robot selection. So do check out those videos because those will be very important to understand the upcoming sessions. Today we will start to learn about what are the different configurations of the robots, and today we will see what is a Cartesian or linear robot. So without wasting time, let's get started. Now you can see one picture on the right hand side corner. So you can try to understand what is O, what is L. So that indicates the motions, the joint motions. So O is nothing but the orthogonal motion and L is the linear motion. So if you carefully observe, you will notice that it will have only linear motions, and that's why the name is linear robot, or it is also known as a prismatic or a gantry or XYZ robot. Now it can move in XYZ direction, or you can configure it in different axes. Like you can have only two axes, also you can have three axes also, depending on your application. So the applications basically include the material handling. It can pick and place the part from one place to another place. Then they are widely used for packaging, 3D printing, and they have many other different applications. Now here one point you need to understand is it cannot move in a very different plane. Let's say if something is at some oblique plane or some having some curvature, then you need to program it, but it cannot follow the exact basic path. Here you can see how it moves. The motion, you can see X, then Y, and then the Z direction. So these are the motions. So as we saw, it is also called as a rectilinear or a prismatic robot. So let's check out the work envelope. Now we know what is a work envelope. So work envelope indicates uh, the volume within which it's it's not required that it should be a volume. It can be a plane, because let's say if it's only a XY robot, then it can move in a plane only. Now it's XYZ, and that's why it has formed a rectangular prism. So that is nothing but the volume in which this robot can operate. These are kind of boundaries, which is nothing but the working envelope of the robot. And here you can see in 2D. So this is the horizontal reach, like a maximum distance from the center, and this is the vertical reach, the maximum distance from the, let's say, base of the robot. So these are also important parameters which are required to understand what is the work envelope. Now let's check out. You can type Yamaha XY robots. Yamaha is one of the manufacturer of different kind of robots, of Cartesian robots. So let's click on Cartesian robot, that is the industrial robot, and it will open one window. So here you can see Cartesian robot. There are different series depending on the characteristics, and you can check out the different configuration: arm type, moving arm type, gantry type, pole type. So this is nothing but the configuration. Again, inside the Cartesian robot, you can arrange the axis in different orientation according to your application. So this is the catalog. Here you can see what are the different series, PX, FX, and you can see they are available in which variations. Then number of axes, you can see the maximum payload. This is what we were discussing, important parameter, maximum stroke. So depending on our requirement, let's say if we want a 20 kg payload, we cannot go for PXYX series, we have to go for MXYX series. So that is how we need to check the payload of the system, then the reach, the stroke. like in whatever distance we want to move the robo, what is our work envelope. And let's check out one series, XY series. This is the catalog for XY series. You can uh, check what are the different configurations again in this series. Then the work envelope arrangement, again in the work envelope, depending on the arrangement of the X and Y series, you can see A1, A2, A3, A4. So it offers four different what you can see, the work envelope configurations. The work envelope size will be same, the configuration will be different. Now specifications, you can see payload, it is given y-axis, the payload according to the stroke it has given in the catalog. As the stroke increases, the payload decreases. Then maximum speed, we have the x-axis and y-axis, then the maximum speed is given. So these are the parameters which are mentioned, and you can check the selection. So here you can see what is the nomenclature and what are the parameters. So this is one series pxyx. We can check what things are mentioned over here. You can see the axis construction, then motor repeatability. That is one of the important parameter which we are discussing. You can see x and y axis repeatability, which is in like a 20 microns, right? Then what we have, the maximum speed, how much maximum speed you can achieve, the range, moving range, and then of course the payloads, which is very important parameter. You need to check the stroke and the payload, because you can observe that with the increase in stroke the payload capacity gets reduced. So these are some of the parameters you need to check. Then it shows in the drawing the work envelope, the dimensions you can check, and these are the different configurations of the work envelope. You can check out the dimensions and you can see whether it can be fitted in your space or not. So this is all about this is about Cartesian or prismatic or a linear robot. Let's check out one application. So here you can see this is kind of a one pick and place application. You can see we have X, Y, and Z motions over here, and the end effector, you can see there is a gripper, so that acts as a end effector, and it is also having rotational motion. So this is how the Cartesian robot works. So this is all about the Cartesian robot. We discussed about the basics, and if you have any doubts, please do write into the comment section and we can discuss over there. Until then, keep intro making. Thank you for your patient listening. Thank you.